Greetings and welcome to this session where we will be talking about pointers and arrays. We will look at how to declare pointers assignment, pointers arithmetic, the relationship between pointers and array, and we will also be talking about pointers and string. A pointer in C++ is a variable whose value is a memory address. With pointers, many memory locations can be referenced. And we have some data structures like linked lists and trees that use pointers. If you recall, when we were talking about variable, we have discussed that a variable is a named memory location. Now, each value represented on your computer is stored at a particular location in memory. All right. Now, to store the actual location or the actual address where the values are, we need a pointer to do so. All right. So while your variable is capable of storing like a particular value, so you may create a variable, could be of type int, maybe called x, that is storing the value 5. The pointer, on the other hand, could be storing the actual location where in memory does that 5 live. That is what the pointer would store. So the pointer stores the memory location. The regular variables cannot store the memory locations. You might be wondering why, are we concerned with the storage of memory location? Now, this will help us in a number of data structure implementations. So if we're implementing like a linked list, could be a binary search tree, among many other things, we need to have a knowledge of the pointers so we can actually use the pointers to manipulate the memory of the computer. All right. So there are two main operators that we will be interacting with as we deal with pointers. So we have the ampersand here, which is the address operator. This one, you would have encountered it when you were using the scanf, and this will give you the address of a particular variable. We have the asterisk. In this case, it's going to be used to dereference the pointer. So if you have a particular pointer, with the use of the asterisk, we can actually find out what the pointer is actually pointing to. All right. So we're going to head over to dev, and we will look at how we go about declaring a pointer. All right. So to start, I'm going to create a variable called x, whose value is 5. All right. So this is a regular variable. This variable has a value 5. All right. However, this variable x, it has a data type, which is obvious on the screen. It's int. This variable x has a value, which is obvious on the screen. It's 5. It also has a memory address associated with it. So there's a memory address at which the 5 is stored. With our naked eyes right now, we cannot see where in memory 5 is stored. It's being stored. All right. However, if we do a printout, so if we say cout, and we use the address operator that we have discussed earlier on, this one, we can get the address where 5 is being stored. So if I say cout address of 5, of x rather, address of x is going to tell me where in memory the 5 is located. And you'll notice that it's going to be displayed as a hexadecimal number. All right. So here's the output. So this is now at this location. As you can see, it's a hexadecimal number. This represents a particular memory location. All right. Now, if we were to print out 5, x itself, you will actually see the actual value, which is 5, coming up on the screen. All right. Let me just break the line so we can see the two of them in different lines. So this is going to print out the value of x, which is 5, and this will print out the actual address where x is located. So let's go ahead. So here we go. So we have the value 5, that's the value of x, and this is where in the location in memory where x is stored, is being stored. All right. So we have a hexadecimal number representing the address. All right. Now, if we want to do anything with the address, if we want to, store that address, what we're saying is that if we create a regular variable, we will not be able to do that. So let's try it with, say, let me say address of x. All right. So let's say we want to store the address of x. Here, I create a regular variable called address of x. And I'm going to try to assign it the address, the actual address, using the ampersand of x. All right. So what we're saying is that this is not possible. We're going to get an error because we cannot store the address in the regular variable. All right. Invalid conversion. All right. Now, if we really want to store the address of x, what we'll have to do is to declare a pointer to store that. So the pointer can store the actual address where the variable is located. We declare the pointer by simply putting an asterisk before the name. So once you see an asterisk here, so the asterisk here is serving two purposes. So here we're using it to declare the pointer. In this case, the pointer is called address x. So this will now be able to store the address where x is located. We also use the asterisk to dereference the pointer. We will see that in a moment. All right, so if I try to run this launch, it will be fine because we are now using a pointer to store the address of. All right, so now that we have defined the pointer by putting the asterisk here, followed by the name, we can now access the value of the pointer. Or we could also print out the address that the pointer is holding. All right, so let me just remove what is here on the screen. So if I say something like cout address of x. So address of x here is going to give you the memory address where 5 is located, because based on what we have at line 8, the pointer address of x is equal to the address of x, right? Ampersand x meaning address of x. So let's see. So here it is. So that's the address of x. And it is possible for the address to change when we run the program, right? Because remember the variables, are capable of changing, and depends on the address that is available. All right, now if we actually want to see, so now that we have the pointer, so we should agree by this that the address of x is storing the address of the variable, right? And this pointer is actually assigned the address of x, as you can see on the screen. So once we run the program, we are actually seeing the memory address that x is located at. Now, if we only have the pointer and we want to see the actual value that the pointer is pointing to, we can dereference the pointer by putting an asterisk here before the name of the pointer. By putting an asterisk before the name of the pointer, we dereference the pointer. So when you dereference the pointer, it's like you uncover the pointer to see what it's pointing to. All right, so if we run this program, instead of seeing the memory address, we're now going to be seeing the actual value. So what we did a while ago was just to dereference the pointer. So by putting an asterisk here, we no longer be seeing the address, but we'll be seeing the actual value that the pointer is pointing to. Again, if I remove the asterisk, I'm going to see the memory address that the pointer is pointing to. All right. Now, let's look some more on how we go about declaring pointer. All right. So we declare a pointer similar to how we would declare just about any other variable. So we can have a pointer to an integer, we can have a pointer to character, and so forth. All right. So this is a basic syntax of how to declare a pointer. So you specify the data type. So if you're declaring a pointer to a double, you'll put double followed by the asterisk and then the pointer's name. So that's how we go about. That's the general form of how we go about declaring a pointer. So you specify the data type, then we have the asterisk. Now, if the asterisk is missing, it simply means it's not a pointer. It's going to be a regular variable. So we have to bear that in mind. All right. So here we have a pointer called xptr. And this is a general naming construct that programmers tend to use for pointers. Not saying that it's mandatory, but it's encouraged because it helps with readability. All right. So here we have xptr, which is a pointer of the pointer to an integer, right? So it's pointing to an integer. So xptr in this case, it's pointing to an integer. cptr here is a pointer to a character, right? So basically, we are saying is that this pointer here can store the memory address of an integer. This pointer down here is capable of storing the address of a character and so forth. All right. Now, the use of the void here is just a generic pointer that can represent just about any type. All right. So we will see more of those as we go along. All right. I would have touched on how to assign values to the pointer, but let's look at another example as to how we may declare a pointer. Let's declare a pointer of, say, double. All right. Let's see. All right. So let's say I have the variable cost is equal to 8,000. It's the same. All right. What we're saying now is we could declare a pointer that stores the memory address of the cost. So we could have something like double, and I'm going to call it cost PTR. Now, if we're defining a pointer called cost PTR, remember very importantly, we need to put the asterisk right here, and that will show that it's actually a pointer that we are. So cost PTR is now capable of storing the address of a double pointer. All right. So here we have declared the pointer called cost PTR. Currently, we do not have anything assigned to it. All right. So if we wish now to assign something to it, we could do the assignment in the same line where it is declared, or we could say cost PTR equal to the address of the double. So in this case, we're going to put the address of, say, cost. Cost is a double. All right. So cost PTR is now storing the address of the cost variable, which is a double of type double. All right. Now, if we were to print out costs PTR, who would like to guess what the output is going to be? All right. If your guess is the memory address of cost, then that is good. So we're going to be seeing a hexadecimal number coming up, which is there. That's the address where cost is located. Again, if we're given just the pointer and we wish to see the actual value at the location where the pointer is, then we can simply dereference the pointer by putting an asterisk here. All right. So the pointer stores the memory address of a variable. And if we want to see the value that is at the location where the pointer is pointing, we simply have to dereference the pointer by using the asterisk, which is called the dereference operator. All right, so if I run this, we will see the actual value. All right, so there's the value of cost. All right. Now, let's look at this. Just to prove that the pointer represents the actual location, the storing the actual location. We could do something like this. So we could change the value of cost using the pointer. So we could say cost PTR. So notice I'm dereferencing the pointer. I could actually change the value. I could say this is equal to say 755.2253. Right? So here I actually change the value of cost without using the cost variable. So let's print out cost and we'll see what's gonna happen. All right. So notice there's no line that says cost is equal to anything down here. However, the actual value of the cost is going to change because we will have changed the value of the pointer. All right. So the cost is going to change from 8,057 cents to 755.23 cents. So let's run and see. All right. So here we go. So the cost is 755.23 cents. All right. So now, when you use the pointer, we are actually saying here that we can use the pointer to manipulate even the value of the variable being stored, right? So you can use the pointer to manipulate the value of the variable. And pointer has been used, in this area in a number of ways. So for example, we want to change the color of the data on the screen and so forth, we can actually use pointers to manipulate the different addresses that controls the color that you have displayed on the screen. All right. So it's very useful, and we will explore more of its use as we go along.